the next topic, which is actually very, very, very important to pretty much the whole foundation of second semester, and that's dimensional analysis. Dimensional analysis is a way of setting up math problems. Yes, I know you can solve some of these problems that we're going to do without doing dimensional analysis for this unit. However, we're learning the basis of how to set up stoichiometry problems second semester. So yes, I know that you can probably figure out how many seconds you've been alive at this moment or whatever without setting up the math problems, and it seems pretty tedious. You can probably pick up a calculator and figure it all out. However, this unit is about the process more than getting the actual answer. The lab that we're going to do, we're going to figure out how many miles or how much of a mile is a pen. Who cares, right? But it's getting to that point that we can actually set up the math problems. That's the important part of this concept. So in order to do math problems using dimensional analysis, you're going to use what's called a conversion factor. And with your conversion factors, your main goal is to set it up where you have a unit on top and a unit on bottom of the next step. And whatever unit you have on top of the previous step, you're going to slide it to the bottom of the next step to get it to cancel. Because mathematically, when you're dealing with proportions and fractions and all that kind of stuff, whatever you have on top and bottom, they end up canceling out. You're going to do the same thing. So I said proportions, that wasn't a proportion. Fractions, sorry. So the big concept here, whatever unit you have on top, on the bottom, has to be the same thing so it cancels. So with your conversion factors, if I can get this to change, there we go. They are on a handout, and it'll say things like 1 foot equals 12 inches. Now you can flip them, top and bottom, however you need to do that. Or it might say like 1 day is equal to 24 hours. Or it might say 1 kilogram is equal to 1,000 grams. 2.2 pounds is equal to 1 kilogram. So you have things like that that you're going to convert between one unit to another. And they're all going to be given to you on a chart that you're going to want handy when you're doing these math problems. So the paper that is in the folder, if you're not face-to-face, if you are face-to-face, you got this in class. But if you're not face-to-face, you're going to want this handy when you're doing any of these math problems, whether it's in the homework or in the lab or on the test or whatever it is. You have these different categories. Now looking at this, this first little chunk up here all has to do with time. So anything that's time related is going to be up here. The next little chunk here is all volume, so you have milliliters, drops, gallons, liters, things like that. Then we have distance or length, so miles, inches, feet, centimeters, kilometers, things like that are all here. Then we have mass, so pounds, grams, kilograms, tons, all of that in here. And then down here, you're not going to use this until next semester, but this is molar mass and this is the mole. This, again, it's on your paper because we're going to use it later on down the road, but this year it's getting split up over this semester, so you won't need any of these right now. And then down here at the bottom, you have your metric conversions. Your metric conversions before, we didn't do the actual math with this. All that we did was we just slid decimal places from left to right and all that kind of stuff with your King Henry died chart. This is a way of using metric conversions without doing moving the decimal. So base unit, remember base units are meter, liter, gram, second for this class. We'll add in a few more second semester, but for right now, meter, liter, gram, second. So when I'm reading this, let's say that I'm dealing with mass, so grams. 1 gram is equal to 1,000 milligrams. So where it says base unit, you fill in the word meter, liter, gram, second, whatever you need. This would be like if it's meters. 1 kilometer is equal to 1,000 meters. So I'm filling in meter both times it says base unit. Or here, 10 milliseconds is equal to 1 centisecond. Or 100 centigrams is equal to 1 gram. So base unit, meter, liter, gram, second, where it has the word base right here, you're filling in meter, liter, gram, second. So with these conversion factors, you're going to have to figure out kind of a pathway on how to get from one unit to another. So it's going to give you a unit in the problem. It might say like, I don't know, you've been alive 15 years. How many seconds does that equal? So you're going to have to look through that list at your different units, and you're going to see, okay, if I have years, how can I get rid of years and turn it into something else? All right, then I'll go to, I don't know, days. So how do I get days and go to something else? Or, days to hours or whatever it is. But you are canceling out units, top to bottom. So when you set it up, you're going to start with a number on the top because it's over 1. And you're going to take whatever unit that is and it goes to the bottom of the next step. And you're going to use that conversion factor to fill it out. Then it's going to turn it into a new unit. Then you have a new unit, so you're going to slide that unit to the bottom, turn it into something else. So you're going to keep manipulating the numbers and you're going to change it from one unit to another. So when you are looking at the math problem and everything, you set it all up first. And once you set it all up, then you're going to get an answer. With your answer, you're going to put it in your calculator. It's going to spit it out. Then we have to deal with sig figs. With your sig figs, you are going to multiply on all of these. You're not going to have any addition or subtraction. So you're multiplying and dividing. When you multiply and divide, you are looking at the measurements to determine your sig figs at the end. Conversion factors are exact amounts. Conversion factors are not measurements. So because a conversion factor is not a measurement, you don't look at your conversion factors when you're looking at your sig figs. Whatever number you start with, however many sig figs are there, you're going to have the same sig figs in the end. They're always going to be the same beginning to end as far as the number of sig figs there. So we've got 3 example problems, and I've got my document camera here, so I'm going to switch it over. I printed this off, and we're going to swap it out here. I've got my conversion factors handy, so I have these ready to go. My first practice problem says, convert 4,800 kilograms into pounds. So I want to go from kilograms to pounds. When you're setting these up, you're always going to give whatever is given at the beginning. And then you're going to have a unit. I'm just going to call it X for right now. Now you can set it up like this, where you have a line and then you kind of break it up like this. And then you're going to have a conversion factor, whatever it is. That unit X has to be the same top to bottom. And then you're going to turn it into, I don't know, unit Y. I'm just making stuff up. So then, because I have the unit on top and bottom, those cancel. Now I have unit Y. Let's say I need to change it into something else. I'm going to put unit Y on the bottom because top to bottom cancels. And then I'm going to turn it into unit Z. I'm just, again, making up numbers. So again, top to bottom, those are going to cancel. That's going to leave me with unit Z. If that's what it's asking for, I'm going to have a number with the unit Z. So this process is identical to doing the same thing where you have a given number, and then again we used X, and then you can do times and then the line. Unit X on the bottom, we turned it into Y. X, ooh, that's why I didn't want to use X. Oh well. X on top and bottom cancels, multiply, line, unit Y, Z. So it's the same thing either way, and I'm going to do the first math problem both ways so you can see it both ways. I don't care if you put times and then a line with the break there, or if you just use, I had an old teacher, she used to call it railroad tracks. It doesn't really look like a railroad track to me, like a picket fence maybe, where you just have the line. I typically do them like this with the line because it helps me to keep track of top and bottom better, and this is what my teachers and professors always taught me. But I'll do both methods on this first problem. You only have to pick one and go from there. So, that all being said, we have kilograms, we need to go to pounds. So if we have kilograms and we need to go to pounds, we're going to look at our conversion factors. Kilograms and pounds are mass. So we're going to look at the mass section here. This one goes grams to ounces. Hey, look here. Kilograms and pounds. This is a one-step process. I'm given kilograms. It takes me to pounds. So because this is a one-step process, I only need one conversion factor. So with this one, I'm going to start with my 4,800 kilograms. Now I'm going to do it like this first, and then again I'm going to rewrite it, and I'm going to show you this method with the line all the way down. Because I have kilograms on top, I have to put kilograms on the bottom to cancel. My conversion factor says that in 1 kilogram, there's 2.2 pounds. So I'm going to put 1 kilogram on the bottom because it says 1 kilogram. Kilogram goes on the bottom. That's equal to 2.2 pounds. Because I have kilogram on top and bottom, those cancel. That leaves me, there we go. It leaves me with pounds, which is what the question's asking for. So I don't have to do any more problem. Now, to get my answer, you multiply all the way across the top. You multiply all the way across the bottom, and you divide the two. So here, we're going to take 4,800 times 2.2. You don't actually have to write this part out. Normally, you would just hold it all in your calculator, but I'm just showing you what I'm doing. This is just 1. So I'm dividing by 1, so that's all the answer that I need. So that means that my answer here is 10,560 pounds. It's divided by 1, so I can ignore that. This number down here has 2 sig figs. So because this number has 2 sig figs, my answer has to have 2 sig figs. So to get this number to have 2 sig figs, I need the 1 and the 0. The 5 makes the 0 go up to a 1. So you actually end up with 11,000 pounds. All math problems are all worth 4 points. For your 4 points, you have to show your work. If you don't show your work, you don't get any credit. In these, you actually have to use dimensional analysis. You have to get the correct answer, you have to use the correct unit, and you have to use sig figs when you give me your answer. Those are your 4 points. Work, the unit, the answer, and then the sig figs. So 4 points for every math problem that we're going to do. Now to show you this setup without using like times and then a line like that, again, this is the exact same process. So we have 4,800 kilograms. I'm going to use a line instead of a times sign. And you have 1 kilogram is equal to 2.2 pounds. Again, kilogram is on top and bottom, that cancels. So we would multiply across the top, multiply the bottom, divide the 2, and you get 11,000 pounds again. So it's the same method either way. It's just personal preference on how you want to write that. Some people like writing it like this. Some people like writing it like this. Now the next one, it says convert 22.5 hours into seconds. So if we have hours and we need to go to seconds, we're going to start with the number that's given in our question. So 22.5 hours. We have to go to seconds. So I'm going to use this method with the line. Because I have hours on top, hours has to go in the bottom of the next step. So I'm going to look at my conversion factor sheet. I'm going to see if there's one step already written on the paper that goes straight from hours to seconds. So this is hours to minutes, days to weeks, hours to days, days to year, second to minute. I don't have just a one-step process to go between hours and seconds, so I'm going to have to go to something else. This one is hours to days. This one is hours to minutes. So it's going to be one of those two. So let's try to work backwards. I have seconds. I need to get to hours. So when I look through my list, this is the only one that has anything with seconds. It says 60 seconds is equal to 1 minute. Now, if I can go from minutes to hours, I know that I have my pathway. So 60 seconds is equal to 1 minute. Hey, look right here, we have minutes to hours. So this is going to be a two-step problem. You could have 6, 7, 8 steps with these. Might just be 1. This one is going to be 2. So right now I have hours on top. I have to get hours to cancel, so that's going to go in the bottom. My conversion factor that I found says 1 hour is equal to 60 minutes because I have hours on top and bottom that cancels. Now I can go from minutes to seconds, so 1 minute is equal to 60 seconds. Minutes on top and bottom cancels. That leaves me with seconds, which is what it's asking for in the question, so I don't have to do anything else there other than grab my calculator and do the math. So this one we're going to multiply all the way across the top. So when you multiply across the top, you're going to take 22.5 times 60 times 60, and you're going to get an answer on the top here. And then you have 1 times 1, and you're going to get an answer on the bottom, which is just 1. Spoiler alert there. 1 times 1 is 1. So here, we have 22.5 times 60 times 60. So I got, for an answer here, 81,000 seconds divided by 1. I need 3 sig figs. So I have 3 sig figs here. I have to have 3 sig figs in my answer. I only have 2 the way that it's written. I have to have 3. This one is going to be one that has to go into scientific notation in order to get the right number of sig figs. So to put this in scientific notation, we start with our decimal. 1, 2, 3, 4 times I'm going to move my decimal. So you get 8.10 times 10 to the 4th seconds. I showed my work. I used the correct unit. My answer is correct, and I have my sig figs. So in terms of this problem, to go from hours to seconds, we had to use 2 different conversion factors. Now the last one, we have 6.9 gallons, and we want to turn that into drops. And I'll show you with the times and the line method. Again, you can pick one and stick with it. It doesn't matter to me which method you go here. But we have 6.9 gallons. We need to go to drops. So I'm going to have to look at my conversion factors to see, do I have a direct pathway to go from gallons to drops? So this one is gallons to liters. And the only one that says drops is right here, drops to milliliters. Well, wait a minute. That doesn't work because I have gallons to liters, but I have drops to milliliters. I need to get some way between milliliters and liters. That is a base unit. It's metric. So my metric conversions, we have to go to the bottom of my paper. When I go to the bottom of my paper, remember we need to get from milliliters to liters. So we're looking milli to base. So here we've got milli to base. So where it says base unit, I'm going to read the word liter. So this says 1 liter is equal to 1,000 milliliters. So that will bridge my gap from milliliters to liters. So this is a 3-step problem. I'm going to go from gallons to liters, liters to milliliters, and then milliliters to drops. So we have gallons on top, so gallon has to go in the bottom of the next step to cancel. The conversion factors there, it says 0.264 gallon is equal to 1 liter. So gallon on top and bottom cancel, that's equal to 1 liter. Now I need to get rid of liters and go to milliliters. So 1 liter is equal to 1,000 milliliters. Liter on top and bottom cancels. Now in the last step, my conversion factor says 1 milliliter is equal to 20 drops. Milliliter on top and bottom cancels. So that leaves me with drops, which is what it's asking me for. So now I'm going to pick up my calculator. When you pick up your calculator, remember you're multiplying all the way across the top first, multiplying all the way across the bottom next, and then dividing the 2. I usually hold it all in my calculator. So use parentheses on the top. 6.9 times 1, we can skip, times 1,000 times 20. Close my parentheses. And then I'm going to hit divided by everything on the bottom. So open parentheses, 0.264 times 1 times 1. Hey, I don't have to do anything there. I'm going to close up my parentheses. So I multiplied across the top, held it in parentheses, divided by, open parentheses, multiply all the way across the bottom, close up my parentheses. This number is my answer in drops. I need 2 sig figs. So if I need 2 sig figs here, I'm going to have 5, 2. The 2 next door makes that 2 stay the same. And then I'm going to fill in 1, 2, 3, 4 spaceholder zeros. My unit is drops. So we have 520,000 drops in 6.9 liters, which is almost 7 milk jugs. So when we're doing these, big takeaway, whatever unit you have on top, it has to go in the bottom of the next step. Usually the hardest thing there is to do with these is looking through your conversion factors and figuring out what pathway you need to use to get from one unit to another. When you are looking at them, big mistake that people make is they forget about these metric conversions down here at the bottom, and then they just kind of give up. So don't forget about those because they do fill in to a lot of the different sections that we have here. If you guys have any questions, make sure that you ask. Remember, show your work using dimensional analysis. Have a great day.